Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercise 17B of circles. Also, to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. In this exercise, mark the fourth sum as IMP and we are going to do questions 2, 4, 6, 8 and 10. Let's start with question 2. The diagram is given. M is the midpoint of O dash, and we have to prove that the chords AB and CD are equal. So we will do one construction here. We will draw OX perpendicular to AB chord and O dash Y perpendicular to CD chord. Now we shall prove these two triangles congruent. We've got OM is equal to O dash M, which is given. We've got vertically opposite angles, these two, and we've got 90, 90, so two angles equal again by construction. So by SAA tests, these two triangles can be proved congruent. That means OX becomes equal to O dash Y by CPCT. And whenever two chords are equidistant from the center of a circle, then the chords are equal. That's a theorem. Now, it's true that these two chords are not in the same circle, but the two circles are equal. Their radii are equal. So the theorem holds even here, which means that if this chord is, let's say, 10 centimeters away from the center of the circle, and even this chord is 10 centimeters away from the center of the circle, and since both the circles are equal, the radii are equal, the circles are congruent, then AB and CD, both the chords are equal. It's the same as saying if this CD chord was in the same circle, let's say out here, and then I would have said that the two chords are equidistant from center O, then wouldn't the two chords be equal? That's the same logic applied here. These are the steps and the reason. Now the fourth sum, which is IMP, the diagram is again given. We have to prove that O dash is half of AB. So again construction, we will draw OX perpendicular to AP chord and O dash Y perpendicular to PB chord. AP is a chord in the small circle and PB is a chord in the bigger circle. Now in quadrilateral O dash Y P, PY is parallel to O dash, which is given in the question itself. These three are parallel. Also, so this is 90 and this is 90. That means even OX and O dash Y are parallel to each other. So this becomes a parallelogram. In fact, it's a rectangle because each angle would be 90 degrees. If it's a rectangle, that means O dash will be equal to XY because opposite sides of a rectangle are equal. But XY can be broken down as XP plus PY. But XP is half of AP. Perpendicular from the center of the circle bisects the chord. Similarly, PY is half of PB. Perpendicular from center of the circle bisects the chord. So XY is actually half of AB. So if O dash is equal to XY and XY is half of AB, that means O dash is half of AB. Proved. Now similarly, O dash is half of CD. We don't have to prove that, it's similarly. So if this is half of this and this is half of this as well. That means AB is equal to CD. That's Roman number 2. Here are the steps. Now, the sixth sum. There's a circle and there's a square, and we have to prove a pair of triangles congruent. It's actually a congruency chapter sum. If you wish, you can draw the triangles separately to visualize them. First, let's talk about triangle OPA, this one, and OQC. This one. So both these triangles have 90 degrees because angle of a square. I can even say that OP is equal to OQ, radii of the same circle. Also OA is equal to OC, side of the same square. So by SAS test, the two triangles are congruent, as you can see here. These are the steps for Roman number 1. Now for Roman number 2, first of all, clearly CP is equal to QA because OC is equal to OA, side of the square. Out of that, OP is equal to OQ, radii of the same circle. So after subtracting that, what is left? CP is equal to QA is left. So that's one thing. So now we can target this triangle PCB and this triangle QAB. So what do we have here? Well, we've got this side equal to this side, we just proved it. And we've got this CB equal to AB, side of the square, sides of the square, and we've got 90-90 angles of the square. So again, SAS test, the two triangles are congruent, and these are the steps. Now the 8th sum, it's a proving sum. Read it, draw the diagram. Let's see if you get it right. What are you waiting for? Go get the door. Somebody rang the bell. This is the diagram. We have to prove CD parallel to AB. Now we'll have to write the given. O is the center, Y is the midpoint of CD, X is the midpoint of AB. These are the conditions given in the question. And also YX is a straight line, which I have written as X dash O dash Y. It simply means Y, O, X are collinear. So we have to prove them parallel. So first of all, if this is a bisector of a chord from the center of the circle is always perpendicular to the chord, 90. Similarly, this is a bisector of the chord from the center of the circle, so it will be perpendicular to the chord. Now, if you look at these two lines, these two angles are called allied angles or co-interior angles, and whenever the co-interior angles are supplementary, that means the lines are parallel. So that's the test to prove that they are parallel. There are many other tests like corresponding angles tests and alternate angles tests, but here the co-interior angles test is valid. Now the 10th sum, read the question and draw the diagram. Done? Okay, does it match this diagram? They have given that the chords are perpendicular to each other, first of all. This is 90. Also, from the center we are drawing two perpendiculars. And we have to prove that this is a rectangle. This is a square. That's what we have to prove. Now, we see 390 degrees angles in this quadrilateral, so automatically this becomes a rectangle in which opposite sides are equal. Now, if I can only prove any pair of adjacent sides as equal, then it automatically becomes a square. Now, they have given that the chords are equal. Chord CD and AB are equal. And we know that equal chords are equidistant from the center of the circle. That's a theorem. That means this is equal to this. So in a rectangle, if a pair of adjacent sides are equal, then it becomes a square. So done.